In the last video we were learning about the basics of stoichiometry. We were learning that the relative atomic mass can be got from the periodic table by adding up the atomic masses of the atoms in a molecule or compound. We can find its molar mass. We also learned that balance equations are important for learning out the ratio of moles, and moles are just our unit, just like newtons or anything like that. They mean an amount of something. So if we know, for example, that we are going to react 2 moles of nitrogen, we know that 6 moles of hydrogen will be involved and 4 moles of ammonia will be made, right, if this is in a completely balanced equation. So I'm just going to turn that from its equilibrium arrow to an arrow to make what we're about to do true. Okay. The first thing that you should always do if you see a question for stoichiometry, in my opinion, is work out the molar masses for things, because they're so easy to do, but more importantly they're the achievement level things that we have to do. So what I do generally is I turn an equation into a grid to try to solve things. So I've got the amount, which is related to the numbers in front, so I like to put that at the top. Amount is measured in moles. That's our funny new unit. So on the left hand side I'm going to put N, which means amount. Under that, I'm going to put little m for mass, and that's in grams. And then under that, I'm going to put my mountains, or my molar mass. The reason I put this on top of this is because that's the calculation. This divided by this will give me the top one. The ratio here is going to be useful as well. So what I'm going to do is I'm assuming this reaction goes to completion, which it actually doesn't, if I'm going to do some research. We're going to go through some information. So we're going to say that, first of all, we're going to start with 1.40 grams of nitrogen. That's what we're going to react. What we want to know is what mass of hydrogen is required minimum to make this go into completion. As I say, this one really doesn't, but it's a nice one to do. What mass of ammonium will be made? Sorry, ammonia. Apologies. Ammonia will be made. And so those 2 boxes of things we're trying to work out. So we're going to need a calculator for these. If you've got one, please get it out. I am going to remind you to pull out numbers, because my mental arithmetic is not quite good enough for the numbers that we're going to be using. As I say, the first thing we can find out about all of these things, which could be useful, is their molar mass. So let's do that. Nitrogen on the periodic table should be roughly 14.0. So if you have your periodic table, which is at the back of your book, I believe, there are, magic, we see that nitrogen is 14.01. How many nitrogen atoms are in a nitrogen molecule? 2, so we need to double that. So we're going to get 28.02 grams per mole. Hydrogen, 1.01. How many hydrogen atoms in a hydrogen molecule? How many hydrogen atoms in one hydrogen molecule? It's H2, there's the hint. 2, cool, okay. So each, ignore the 3 for now, that's not the formula is H2. So it's made up of 2 of them. So this is going to be 2.02 grams per mole. And finally, NH3, so that's 14.01 plus 1.01 plus 1.01 plus 1.01. So my maths, and please correct me if I'm wrong, is that is 17.04 grams per mole. Am I right? So let's check that complete. 1.01 times 3 plus 14.01. Cool? Okay. So you can look at the video later and rewind it if you're a little unsure. But remember, nitrogen as an atom is 14.01, and hydrogen as an atom is 1.01. So I've just gone 1 nitrogen plus 3 hydrogens, get 17.04. Okay. You notice there's absolutely no pattern down here at all. Alright, so that's not something you can use in any other way. Then what I'm going to do is my N equals little m over big N equation. Well, only one of those this will work for, because only one of those has got a single unknown. So maths again. Alright? So if I go little m over big M, and this is where I'm relying on you calculator people, because I should be able to do this in my brain, 1.40 divided by 28.02 equals, I need an answer called out for me there, please. Should go back to 0.049 something, is it? 0.0499. Okay, so basically, if I went to three significant figures, 0.0500, isn't it? Yep, when I do the rounding off. Because that next number was a 6, so that would round up, which would round the 9 up, which would round the 9 up, which would round the 4 up. So, sorry, MOL. They abbreviate mole really well, from MOLE to MOL. Useful abbreviation. Okay, going back to what we were doing before, playing with ratios. If there's one of those, there's how many of those? If there's one of those, how many of those would there be? If there's 1 mole of those, how many of those would there be? 3 moles. Good. So if there's 0.05 of those, how many of those are there going to be? Brilliant. 0.150. Let's keep our 3 significant figures. Moles. Okay. If there's 0.1, sorry, start again. There's 0.0500 moles of that. How many of these are there? Brilliant. 0.100 moles. Can we see that there's only one variable in each column now? Fantastic. We're about to solve. So now this equation here gets rearranged. Shuffle, 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 and we get m, which is what we're trying to find. This is our mass row. M equals n times m. So now, I shouldn't need to calculate it, but I do. Could someone go 0.150 times 2.02, please?
0.03.
3 as simple as we can, please. It's exactly 0.03 or 0.030. 0.004. 33. Cool. And that'll be grams. So not much. Pretty hard to measure actually. And in this one, you hope I get this one in my mind, 0.1 times 17.04 is going to be 1.70 grams, isn't it? However, a little bit of an issue here. Oh no, it's not. It's done the double, sorry. 1.70 grams. Is it 0.03 or 0.3? 0.3. I thought I wrote it down wrong. You said it right. I copied wrong. Thank you. And if you have a look here, what do you notice about the trend in the middle line? What do you notice about a trend here? It adds up. Right. This is a thing called conservation of mass. If they don't add up, we've done something wrong. Alright, they have to. Because matter cannot be created nor destroyed by a chemical reaction. It can be, but it's not a chemical reaction that does that. This is only a chemical reaction. Annihilation events, creation events, those sorts of things. Antimatter meeting matter, that sort of thing. Okay, so stuff I don't understand properly. Alright, so that's where we're headed. We want to be at the stage where you can do this in a week.